Let's prove some half-angle identities. In order to do this, we're going to use our power reduction formulas. So we're going to start with something like sine squared of u equals 1 minus cosine of 2u over 2, and then figure out how we can go from that to figuring out what sine of u over 2 is. So we're literally going to start with that one. So we have cosine of 2u, or 1 minus cosine of 2u, over 2 is the same thing as sine squared of u. What I'm going to do is I'm going to take the replacement of, take u, wherever u is, I'm going to replace it with u divided by 2, because then we'll have u divided by 2 here, and then this will become just 2 times u divided by 2, which is just u. This way we can figure out what sine of u over 2 is. So 1 minus cosine of 2u, well, being replaced with u over 2 will give us u equals sine squared of u over 2. All I did is I cut each of the angles in half. If I cut both the angles in half, the relationship is still the same. So that's what I did here. Now, I'm going to solve for this. Well, how do I do that? I'm going to take the square root of both sides. And when I take the square root of both sides, I should take plus or minus the square root of both sides. Now, it's worth pointing out that sine of u over 2 is not going to be both positive and negative. It will depend on what quadrant this is in. So, depending on the quadrant of u over 2. And this is also going to be true when we get our cosine formula. Depending on the quadrant of u over 2, this is going to be plus or minus the square root of 1 minus cosine u over 2. Let's do the same thing for cosine. We'll start with 1 plus cosine 2u over 2, which was our power reduction formula for cosine. And just as before, we're going to replace u with u over 2, which will take 2u and turn it into u. And then we'll have cosine squared of u over 2 equals that. Solve for cosine, and we get plus or minus 1 plus cosine of u all over 2. And that's going to be our answer. And once again, it's going to be depending on the sign of the value. Okay, tangent. Tangent, well, by the quotient identity, this is sine of u over 2 divided by cosine of u over 2. And we just figured out what those formulas were. We have square root of 1 minus cosine of u over 2 divided by 1 plus cosine of u over 2. If we rewrite this division, we have 1 minus cosine of u over 2 times 2 over 1 plus cosine of u. The 2's cancel out, and we're left with square root of 1 minus cosine of u over 1 plus the cosine of u. Now, this is not going to be an acceptable final answer. You could write it this way, but no one ever does. What we typically will do is rationalize this denominator by multiplying by square root of 1 plus cosine. 1 minus cosine over 1 minus cosine. In the numerator, we'll take something times itself. No. 1 plus. Okay, we'll take something times itself in the denominator, and we'll just be left with 1 plus cosine of u. And in the numerator, we'll have square root of 1 minus cosine times 1 plus cosine. That's a difference of squares, So this is going to be 1 minus cosine squared. Ooh, this is a Pythagorean identity. So we have square root of, by our Pythagorean identity, that's sine squared all over 1 plus cosine of u. And square root of sine squared is sine. So we have sine of 1 plus cosine u. So this is one of our identities. However, we could, if we wanted to, so this is an acceptable final answer. And then there's a second identity we can get out of this. If we take sine u over 1 plus cosine u and multiply by the conjugate, 1 minus cosine over 1 minus cosine, we'll get sine times 1 minus cosine, and in the denominator, we'll have, once again, 1 minus cosine squared. Ooh, that's a Pythagorean identity. So that becomes sine u, 1 minus cosine u, over, this all becomes sine squared. If that's all sine squared, then a sine cancels out with a squared, and we get 1 minus cosine u over sine u. So this is also equal to tangent of u over 2. Tangent of u over 2 equals sine over 1 plus cosine, or 1 minus cosine over sine. Thank you.